All right then, let's go through this question. Let's read question number 8. Now question number 8, it says in the diagram below, P, M, T, and R are points on a circle having center O. PR produced meets MS at S, radii OM and OR, and the chords MT and TR are drawn. Angle T1 is equals to 148 degrees, P angle OM is equals to 18 degrees, and angle S is equals to 43 degrees. Now, this is a given diagram based on this information. All information that has been indicated here on the statement, it is also shown here in the diagram. Now we are given the size of angles which are provided, and we are also indicated the angles that have been told in the statement on the diagram. Now let us go through this question and see what does the question have for us. Now the first question, calculate with reasons the size of angle P, calculate angle O1, calculate O angle MS, calculate angle R3 if it is given that the T angle MS is equals to 6 degrees. All of these questions worth 2 marks. Okay, now the first question here, it says we're gonna have to calculate angle P, 8.1.1, 8.1.1. We're gonna have to calculate the magnitude of angle P. So now how are we going to, let's talk before we do calculation. So how are we going to calculate the magnitude of angle P? Now where is angle P located? Okay, definitely all of you can tell that you see theorem number 2, whereby this angle at center, it is going to be twice angle at circumference, which is true. That's how you can determine the magnitude of angle P. But the problem is we don't know the magnitude of angle O1, so we can't apply theorem number 2 since we are not given the magnitude of angle O1. So in order for us to determine the magnitude of angle P again, angle P is situated in a cyclic quadrilateral. So we have MTRP. MTRP is a four-sided figure. It has 4 sides. 1, 2, 3, 4. It's a figure with 4 sides. Now because we have that figure, all of the vertices of this figure are at the circumference of a circle. Now we are safe to use a cyclic quadrilateral theorem. So to determine the magnitude of angle P, we have given the opposite angle of this figure, which is quadrilateral. We have given the opposite angle, which is angle T1, which is equals to 148 degrees. So we're going to use angle T1 to determine angle P. So now what are we going to say for 8.1.1? Remember, we are asked to determine the magnitude of angle P. So to determine the magnitude of angle P, we're going to say angle P plus angle T1 is equals to 180 degrees. So remember, in Euclidean geometry, we write the statement and the reason. Why are we writing this statement? Why are we saying angle P plus angle T1 is equals to 180 degrees? Because we are talking about the opposite angles of a cyclic quad, meaning opposite angles of a cyclic quadrilateral, they add up to 180 degrees. Now we know the magnitude of angle T1, but we are looking for the magnitude of angle P. So we're gonna say angle P, and what is the magnitude of angle T1? It's given to be 148 degrees is equals to 180 degrees, and therefore we have angle P is equals to 118 degrees. We transpose 148 to the other side, it changes sign, we have negative 148 degrees. Therefore angle P is equals to 180 minus 148 is 32 degrees, meaning that's the magnitude of angle P. Angle P is equals to 32 degrees. Okay, now let us move on to the second question. The second question, it says Calculate with reasons the size of angle O1. Now let's go back to our diagram or our figure per se. Now we are asked to determine the magnitude of angle O1. Now we can talk theorem number 2, whereby we're gonna say angle at center is twice angle at circumference, or angle at circumference is half angle at center. That's how we use theorem number 2. Now to calculate angle O1, which is angle at center, it is subtended by this arc MR. Can you see that? It is subtended by arc MR. So we're gonna say 8.1.2, we're gonna say to determine angle O1, you're gonna say angle O1, which is the angle at center, is twice angle at circumference. In this case, angle at circumference is P. Angle at circumference here, and you also give a reason why are you saying this. So your reason, it is straightforward. You're just gonna say angle at center is twice angle let me do this, I'm sorry about that. You're gonna say is twice angle at I was not supposed to write angles angle at meaning angle at the circumference. Okay, that's how you give reason for that. I'm sorry about the video, guys, because I don't have the proper instrument materials to do this video, so I'm just trying here. So we have already determined the magnitude of angle P, so it's gonna say 2 multiplied by 32 degrees, and therefore angle O1, which is what we are looking for, is 64 degrees. 2 multiplied by 32 is 64 degrees. Okay, so that's how we calculate angle O1. Now we move on to 8.1.3. We're gonna calculate or to determine the magnitude of O angle MS. So what is O angle MS? Look, O angle MS, it is basically the whole angle. It is basically the whole angle, meaning we're gonna have to determine the magnitude of this angle. Now how are we going to determine the magnitude of that angle? Sorry. So we have already determined the magnitude of angle P. We said angle P is equals to 32 degrees. We know the magnitude of that. Now let us talk about this triangle, this big triangle MSP. Can you see that? MSP. We have the interior angles. Yes, we have this angle, we have that angle. We can determine this angle, this big angle. We can determine it. Okay, so first let's determine this big angle. So 8.1.3, we're gonna say in triangle MSP, in triangle MSP, what is happening in that triangle? Angle M plus angle S plus angle P is equals to 180 degrees. And what is the reason? Sum of angles in a triangle. Okay, now what is the magnitude of angle M? Angle M is what we are basically looking for. And what is the magnitude of angle S? Angle S is equals to 43 degrees. 43 degrees. And then what is the magnitude of angle P? Angle P, we have just calculated it to be 32 degrees, is equals to 180 degrees. And therefore now let's work our numbers out. But we can work this. What is it? It's 43, right? Let me see this. It's 43 plus 32 is how much? It's simple. It's 75 degrees is equals to 180 degrees, and we transpose 70 side the other side. Angle M is equals to we're just gonna say 180 minus 75, meaning it's 105 degrees. So this big angle from here to here, basically it's 105. So to determine this angle, which is OMS, we're gonna say the big angle minus 18 degrees. So O angle MS is equals to 105 degrees minus 18 degrees, and therefore our final answer is going to be 87 degrees. 87 degrees. That's the magnitude of O angle MS. Okay. That is 8.1.3. Now, as we continue, they say to us 8.1.4, calculate with reasons the size of angle R3 if it is given that T angle MS is equals to 6 degrees. Now, T angle MS is given. T angle MS, meaning this smaller angle. So here we have 6 degrees. We are given this angle. Already we have determined the magnitude of that angle. Okay, so we are asked to determine angle R3. Where, look, where is it located? It's very far. Now this is what we are going to do. First, you're gonna have to determine angle R1 and R2, meaning we have to determine TRP. We have to determine the magnitude of this angle, which is possible for us to determine it. So remember, we have talked about a cyclic quadrilateral. We said MTRP is a cyclic quadrilateral. That means the sum of opposite angles, they add up to 180 degrees. So we have already given that this angle is 6 degrees, and we have determined the magnitude of the whole angle. We got that O angle MS is equals to 87 degrees. So to determine this angle, we're gonna say 87 degrees minus 6, because we are told this angle is 6 degrees. 87 degrees minus 6 degrees, it is this angle, which is 81 degrees. Basically, this angle is 81 degrees. So we're gonna say 81 plus TRP, which is this angle, they add up to 180 degrees, and then we're gonna be able, after determining this angle, we're gonna be able to determine R3 using angles on a straight line. Now let's write it down. 8.1.4. Remember, first thing first, we're gonna have to determine, let's call this M1, M2. So we're gonna determine M2. Angle M2 is equals to 81 degrees. Okay, and therefore I'm going to say angle M2 plus TRP. T angle RP is equals to 180 degrees. The reason is opposite angles of a cyclic quad, and therefore angle M2 is 81 degrees plus T angle RP is equals to 180 degrees. T angle RP is equals to, we're gonna say 180 minus 81. It's supposed to be 99 degrees. 99 degrees. So that means T angle RP is equals to 99 degrees. So we managed to get this angle. TRP is equals to 99 degrees. So to determine angle R3, we're gonna use angles on a straight line. So we're gonna say T angle RP plus angle R3 is equals to 180 degrees sum of angles on a straight line. Okay, and therefore T angle RP is equals to 99 degrees plus angle R3 is equals to 180 degrees, and therefore angle R3 is equals to 180 degrees minus 99, it is equals to 81 degrees. Is equals to 81 degrees. So that's the magnitude of angle R3.